Hey there, and welcome to NASA Launchpad. I'm Justin Tully. Clouds. We've all seen them. A seemingly normal part of this planet we call Earth. But have you ever seen a blue cloud? Or what about one that looks like it's glowing? No? Well, I can assure you that they do exist, and scientists are very interested in these special clouds. Known as noctulucent, or night-shining clouds, these high-in-the-sky brethren of everyday clouds are actually more common than you might think. First discovered in 1885, many scientists have been intrigued by these shiny clouds for years, but had very little in the way of technology to study them. However, because of advances in science, scientists are learning a lot more about noctilucent clouds. These glowing clouds are a bit different than the clouds we're all used to. You can see regular clouds virtually anywhere on Earth, but you can only see noctilucent clouds at around 55 degrees latitude or higher. You're watching a time-lapse video of these beautiful night-shining clouds. It's pretty neat. Regular clouds are found from ground level, we call those clouds fog, to about 9 kilometers, or roughly 6 miles in the sky. Whereas noctilucent clouds are found at a whopping 83 kilometers, or 50 miles above the surface. That's in the very upper limits of our atmosphere, right on the edge of space, literally. And unlike normal clouds, noctilucent clouds are only visible in whatever hemisphere is experiencing summer. Because these clouds are so high up, it makes them really tough to see. The optimal viewing time for noctilucent clouds is right before the sunrise or right after sunset. This is because noctilucent clouds are high enough in our atmosphere to still be illuminated by the sun, while normal, low-flying clouds are not. Okay, so before we get further into this, let's go over the 3 things you need to make a cloud. It's actually very simple. You need temperatures below the frost point, water vapor, and a nucleation site, like a particle, something for the water vapor to grab onto. So when the water vapor comes into contact with a high-altitude particle, the vapor begins to form a mass around the particle, making it the center or nucleation site. And as more and more water attaches to the particle, it slowly becomes visible, and poof, you've got yourself a cloud. In order to study these night-shining clouds better, scientists needed to get a closer look at them, so they worked together with engineers to launch the Aeronomy of Ice in the Mesosphere mission, or AIM. Yeah, you heard me, mesosphere. You know? You don't know? Okay. Remember that scientists divide Earth's atmosphere into 4 layers. The atmosphere is thickest, or more dense, near the surface, and thins out the higher you go until it eventually merges with space. Troposphere is the first layer just above Earth's surface. Although it's not very high, only about 12 to 16 kilometers, about half of our atmosphere is in this layer, and this is where weather occurs. The stratosphere is next. It's also a pretty stable layer, and this is where you'll see most jet aircraft flying. The ozone layer, found here, absorbs most of the harmful rays from the sun, protecting us on Earth. Next layer, the mesosphere. This is the layer that is home for these beautiful noctilucent clouds, and the part of the atmosphere where meteors or rock fragments burn up. The thermosphere is the widest band of our atmosphere, stretching out almost 300 kilometers above Earth. Here you'll find those awesome auroras, and this is where the space shuttle actually flies. The atmosphere here is very thin as it merges into the exosphere. This is the boundary area where the atmosphere ends and space begins. So you can see why scientists might need a special kind of satellite to help gather data about these interesting clouds found kilometers above ordinary clouds. But instead of me telling you about noctilucent clouds, I'm going to refer you to an expert on the subject. Dr. James Russell is the principal investigator for the AIM mission, and recently met up with our cameras to shed some light on these peculiar clouds and fill us in on some of the things we've learned thanks to the AIM mission.
First off, we now see that these clouds are much brighter than what we thought, because now we have a much higher resolution data spatially. We can see these, the brightness of the clouds. When you look at these clouds and you see them visibly, what you're looking at is the clouds in a very narrow layer, about 3 kilometers or 2 miles in thickness. But when you, now what we know is from AIM that they really exist over a range of about 7 miles in thickness.
How about that? AIM has also helped to answer the question, just how do these clouds form so high in our atmosphere? The answer, Dr. Russell?
And there were 3 main theories for these particles. One was cosmic smoke, which is micrometeorites coming into the atmosphere, and the micrometeorites then burn up And what's left over are these very tiny smoke particles, a nanometer in size, about the size of a human hair. Well, what AIM has shown now is that the cosmic smoke, which we're measuring with the AIM instrument, is a dominant source of nucleation particles for the water to condense on and grow.
So the clouds are made from small pieces of meteors, or micrometeors. Pretty cool. These clouds were once only seen in polar regions, but in recent years, there have been more clouds than ever, and they've been making their way to more parts of our planet. So why? There could be a few explanations, but the major theory on why this is happening has to do with a subject you've probably been hearing a lot about lately: climate change.
We think there is a connection, and the connection is something that you might not think about. The reason we have global warming down low is because CO2 builds up in the atmosphere. That's the main reason for it. When we burn fossil fuels, CO2 builds up, and CO2 acts like a blanket, a thick blanket, and so it absorbs heat from the Earth and re-radiates it back to the Earth and makes the atmosphere warm. But up high, where the clouds are on the edge of space, the blanket is very thin. So CO2 built up there actually causes you to lose heat and makes the atmosphere cool. So with CO2 buildup over a long time, then the atmosphere can cool, and we've shown with models that this indeed can happen. And cooling atmosphere makes conditions more favorable for forming clouds, because you got to have cold temperatures, and if they stay colder longer, and if that coldness goes to lower latitudes than what it has in the past, and you'll start to see more clouds and over a broader latitude range than what you would if the atmosphere were not colder.
So what's going on here? Well, our planet is changing, and thanks to scientists like Dr. Russell, we're able to understand a little more of what's happening. So the next time you find yourself at a high latitude, sometime in summer right after a sunset, look up and remember, some clouds really do have a silver lining, or at least they look like they do. Thanks for watching NASA Launchpad. Until next time, I'm Justin Tully.